Hey guys, welcome back. Now in this video tutorial I will be introducing a new sensor. It's a magnetic sensor. It says that the name is MMC2460MT. Now let's face this sensor is available on the website, that is controleverything.com, and to gain more knowledge about this sensor, what we're gonna do is to search this sensor, and what we got is a plus minus 6 Gauss low noise 2-axis magnetic sensor. It's a MMC2460MT, and these are some more features you can see here. You can also purchase the sensor from this website. Now I will be interfacing the magnetic sensor MMC2460MT with a Raspberry Pi and a Python code, and for that I will be going to the resource tab, and from there a Python code sample is here. Now I can download the Python code sample as a zip file, same as you. Also, you can have the opportunity to download the code from GitHub, and the repository there is Control Everything Community. Now what we need is to make some connections for the hardware so that we can pursue this sensor along with the working condition in this video. Let's have it. Now first of all, for the hardware setup we require a Raspberry Pi, which you are able to see here on my screen, and these are the GPIO pins of the Raspberry Pi. Next, this is an I2C Shield. It's available on the website controleverything.com, and the reason we are using this is to make connections with other I2C devices, and the connection should be made easy. So that's why. Now gently place over the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. The other thing we require is the magnetic sensor, that is MMC2460MT. Now this here is a connecting cable. Now make a connection among the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for the I2C Shield. The next part is we need a power source, power medium, that is a micro USB cable just like this, and gently insert it over the power jack. The last thing we need is to make an internet connection with the Raspberry Pi, and for that there are two mediums. The first medium is an Ethernet cable or LAN cable, and here it is, and gently insert it over the Ethernet jack. The next part is a wireless nano USB adapter. This is very useful and it might save your day also. So we are done with the connections part. Now what we require is to have a look over a code. Let's see what we got there. Now for the interfacing of the Python code, what we gonna do is to log into the website, that is github.com, and here we have to search for the repository, that is Control Everything Community. Now get back here and let's see what we got in the sensor, and it's MMC2460MT, and this is the Python code we are looking forward to explore. But let's have a look over the instructions we need to follow to pursue this code. It says that we have to download and install SMBus library on the Raspberry Pi, and steps to install the SMBus are being provided on this very link. Let's open up this link to familiarize ourselves with the relevant information regarding the installation steps. Please note down all the relevant information and do install the setup carefully. Now this is the command to run the Python code. Note it down also. Now get back to the code. As you can see, it's a py extension file at the very end. Now in the code, do notice that we have to import SMBus and time libraries, as you can see, and we have the address of the sensor, that is 0x30. Now in the writing section we have to select control register, that is 0x07, and we are sending the command, that is 0x23, which comprises of initiate measurement, continuous measure mode on frequency 1.5 Hz, no boost, set done, no reset, no refill, cap, and the writing command is here. After that we want to get the data back from the sensor, that's the reading part, and we are reading the data back from the register, that is 0x00, and we are reading 4 bytes of data for the magnetic field axis for X and Y perpendicular axis. As you can see, the sensor is a 2-axis magnetic sensor. Then we have the conversion of the data takes place here, which is according to the guidelines provided in the data sheet for the magnetic sensor MMC2460MT. At the very end of our code, we have to display the output result on the screen, and it goes for magnetic field in X and Y axis, and it's the raw values, which can be positive and can be negative depending upon the nature of the magnetic field present at that particular time. So what we're gonna do now is to show the practicality, the working of this code along with the sensor. So let's have it. Now for the working environment section, first of all, the step is to copy this entire code of the Python and then open up the terminal for the Raspberry Pi via internet. Here create a new file MMC2460MT, which is the name of the sensor.py, which is the extension for the Python file, and here paste the entire code and then save it. And we are done. Now what we require is to go for the command to run, and let's see what we got there. As you can see, we have the magnetic field in x and y axis, and it's almost constant. But when I place a bar magnet near the sensor and run the command, you can see the change in the magnetic field as I am rotating the sensor over the bar magnet over the sensor. So let's see what we got there, and we have the different values, the different raw values for magnetic field in x and y axis. So this is how the sensor works along with the Python code and the Raspberry. Now what do we require is to have a look over the benefit applications of this particular magnetic sensor, that is MMC2460MT. The MMC2460MT is a complete 2-axis magnetic sensor with on-chip signal processing and integrated I2C bus. The device can be connected directly to a microprocessor, eliminating the need for A to D converters or timing resources. It can measure magnetic fields within the full-scale range of ±6 Gauss with 0.25 milligauss per LSB resolution in 16-bit operation mode or 0.8 milligauss total RMS noise, enabling heading accuracies of less than 1 degrees in electronic compass applications. Due to these features, it's applicable in a lot of applications such as electronic compassing, GPS navigation assist, magnetic field measurement. This sensor is available and can be purchased from the website, that is controleverything.com, and you can have the code from the resource tab as a zip file. You can also have the code from github.com and the repository, there is Control Everything community. Now I would like to make it clear that in case of any queries regarding any part of this video or the sensor, you can have your queries on controleverything.com and you can post your comments on the community page. For blogs and articles, you can go to our page of instructables.com, and to subscribe more video tutorials like this, go to our YouTube channel page. Now, I hope you enjoyed this video and have a good one yourself too. Thanks for watching. Thanks a lot.